Hi everyone. This more or likely is going to be the last one of these videos. It's a very short one. It's really basically to kind of round off the last part of the electronics course, and the component we're going to kind of focus a wee bit more on is the relay. We did mention the relay a few weeks ago when we did the components and the symbols, etc. So it's a very short, one slide basically, about a relay and what the role it plays in these type of circuits. So first of all, there's a wee short video clip that I'll show you in a second. Basically what we have is the same as this circuit. Now this circuit here, I've completely simplified the electrical connections, etc. So this is just to show you this is the circuit that sort of goes with that. So what we've got here on the left hand side is your sensing circuit. So you've got your LDR in the lower half. So if you've been paying attention over the last wee while, you'll recognise that this circuit is going to react to low light levels. So it's reacting to darkness. We've got a transistor here, an NPN transistor, which will switch on when it gets to 0.7. The LED indicator, just to show the transistor is operating. And this time the output from the transistor is going via this thing here called a transducer driver. Now that's basically just an amplifier board for these wee kits in order to operate the relay. So the transducer driver is just a necessary thing we have to have in the circuit, but it's the relay here at the end that's the important part. And the symbol here is a wee bit confusing. This is the symbol as you should recognize it and be able to recognize it in an exam. And onto the right hand side of the relay as the output of the relay, you have a completely separate high voltage, high current circuit with we're just using a wee bulb here just now, but this bulb is going to mimic like street lights, as you're going to see in a second. So I'll start playing the video. Hopefully it will zoom in a wee bit. There we go. So there's your low light level sensor, transistor, and the relay. And the output from the relay, as you'll see in a second, connected by some wiring to a lamp and a completely separate power supply. So in reality, this could be mains voltage or even higher voltage and currents. And so the relay is switching on a completely separate circuit from the circuit that's used for the electronics, for the LDR and the transducer driver and the transistor. So, okay, I'll cover up the LDR. You can see the transistor switches on. You can see the LED coming on, and it switches on this lamp automatically. Just all controlled by darkness or lack of light. And so this, it's going to play again. So yeah, your main thing that you need to remember is what a relay is. It's an electrically operated switch which applies a low voltage to the left hand side here of the relay, to the coil, this bit here. That becomes magnetized and it pulls that switch shut on this high voltage, high current circuit. And the dotted line here just represents where the relay is. There's no electrical connection between this left hand side circuit and the high voltage circuits. And the big advantage of a relay is that it uses, and something you need to remember, is it uses a low voltage electronic circuit, which will be thin wires, cheaper, to switch on a high voltage, high current, high power circuit on the right hand side here. And that saves money basically. So this left hand side here is the LDR on the lower half of the voltage divider, so that's sensing low light levels. It's going to react to low light levels. We've got our transistor switch, it's an NPN, so that would switch on at 0.7. Here is your relay with the coil, which when the LDR sends a signal, the voltage is big enough to switch on the transistor. There's a signal or a voltage applied across this coil, becomes a magnet, closes the switch again. I'm kind of repeating myself, but just to emphasize it, and it switches on this high voltage, high current, completely separate circuit on the right hand side. And this is a model for a circuit that could be used to switch on street lights automatically when it gets dark. But your main thing for tonight or today, excuse me, is remembering this learning outcome here, that relays enable low voltage electronic circuits to switch on high voltage, high current circuits. And that's us. That's electronics finished.